In this video, we're going to talk about analyzing graphs of functions, part 1. There are 3 parts altogether. In part 1, we're going to discuss domain and range and finding x and y intercepts. So there's a couple of different ways we can talk about domain and range. Domain are all of our x values. They're called input or inputs. And then when you look at a graph, you want to think of what is that graph doing from the left to the right. The range is the opposite. It is all the y values. We call it the output or output values. And when looking at a graph, we think about what is happening to that graph going from the bottom to the top or up and down. So 2 good examples right here. I've tried to draw it all out for you. So letter A shows you a function f of x equals x squared minus 2. And I just wanted you to see that you could be given a table of values, you could be given the equation, you could be given a set of ordered pairs, or you could just be given the graph. Not as necessarily all together, you might just be given some of that, and you're asked to find domain and range. So from a table or ordered pairs, you would just simply list out the values for domain and range as they were given. And typically we list them from smallest to largest, and you don't have to list them if they repeat each other. So for instance, domain, you just look in the table of values, or you look at every first value of the ordered pairs and you list them out smallest to largest. And then for the range, notice I didn't repeat the ones that were repeatable, and I put them smallest to largest. So -2, -1, 2, and 7, which also goes with the second value of each ordered pair. So if you were given a table or ordered pairs, that is how you would state domain and range. From our graph, it works a little differently. So looking over here at the graph, if that's all you're given, you want to think of what's happening for the domain to your graph going left and right. So to the right, it's going to continue going to the right forever and ever slightly. And then over here on the left, it's going to keep going slightly to the left. So forever, because that's what those little arrows mean, it's going to continue, it would go forever. So from left to right, we say it would be all real numbers. We can denote that with a big R that has 2 lines for the line that you start your R with. And then with interval notation, we put a parentheses because it's not equal to negative infinity. And it goes from negative infinity to positive infinity. And then another parentheses because those indicate that it's not equal to the infinities. But those are a couple ways we could write that. So all real numbers for domain because it goes left and right forever. The range is a little different. So you think of your graph like up and down, what's happening to this graph? So it's going up forever according to our arrows, but it does not go down forever. It stops at -2. It's equal to -2, but doesn't go any lower than that. So we would say y is greater than or equal to -2, or we could use interval notation and put a bracket because it's equal to -2, and then it goes up to positive infinity, and you put a parentheses because it never equals infinity. Okay, so let's look at another one. So what if we're given this cubic function? Again, you could be given a graph of the function, you could be given a table of values, or a set of ordered pairs. So again, from our table or ordered pairs, so if you were not given this graph, you would just simply list out values for your domain and range. So I'm going to cover that up for a minute. And list them from smallest to largest. So I just simply listed out the ones that correspond with the table or the ordered pairs. But from the graph, you gotta see what's happening here. So from the graph, act like you weren't given these table of values. I would say the domain is what's happening to that graph. Let me cover that up. From the left to the right. So these little arrows, you gotta think of what's happening on those little arrows, the ends of our graph. They are going to continue going slightly to the right and slightly to the left forever again. So we say that's all real numbers, or we can write it with interval notation as -infinity to positive infinity. And the range is actually doing the same thing. It's going to go up forever and down forever. So we state the range would also be all real numbers, or interval notation would be negative infinity to positive infinity. Okay, so let's move on to, let's see. So just looking at domain from an equation, because we haven't talked much about that. We talked about table, ordered pairs, and graphs. So now thinking of just an equation, there are three main things that happen with any equation you would be given. So let me cover this up for a second. The domain of any polynomial would be all real numbers. So whenever you see any polynomial, you know that's automatically going to be the domain of it. The domain of a rational function, is all real numbers except for anything that would make the denominator equal to 0. And then the domain of a radical function, so something with a root, will depend on the root. So if you have an even root, for example, you have a square root or a fourth root, or if you happen to have a sixth root, things that are even numbered roots, your domain would have to be all real numbers that are greater than or equal to 0. In other words, think about a square root can't have a negative underneath it. So that would be what would limit our domain if we're given a square root function. If we're given an odd root, so like a cube root, for example, there are no limits because it could be negative underneath. So your domain, again, would be all real numbers. And the nice thing is any function you're given would be one of these three rules, and so you don't have to keep a whole bunch of that in your brain, just those three. Now let's look at these examples, and we're going to work on them together. For example 1, we are just given a list of ordered pairs. So to find the domain, we would do what we did on the page before. We would pick out the first value of each ordered pair and we list it. Let's first check to make sure they're paired up with only one value for y, because that's important. So -3 goes with 0, -1 goes with 4, 0 goes with 2, 2 goes with 2, 4 goes with -1. So no value of x has two values of y. So of course that's important to check first. And then our domain would be -3, -1, 0, 2, and 4. So they're already kind of in order for us, so that's nice. And that's all we have to do. B is a rational function because it has a ratio or a fraction. So that falls into the second rule up here. Our x can be any value as long as it does not make the denominator 0. So think of what value for x would make this denominator 0. So we would say if x plus 5 equals 0, and you solve that little equation, x equals -5. So we would say the domain would be all real numbers except -5. You can also state that as all real numbers x is not equal to -5 is another way to write that. Then example C has volume of a sphere. So think about volume of a sphere for just a minute. So you think about a circle that has a volume. That volume can certainly not be negative. And it's most likely not going to just be 0. So we would need to say that our R value would be greater than or equal to 0 because it's possible to be 0. So it's just never going to be a negative number. So to state that, we could simply say R is greater than or equal to 0, or our domain would be all real numbers greater than or equal to 0. We could say with a bracket 0 to positive infinity is another way to write it. Because it is possible to have no volume. It's just not possible to have a negative volume. Then for h of x, example D here, we just need to think of a square root. A square root cannot be negative. So cannot have a negative underneath. Equal to a negative number. So we think about what would make this be a negative number. So 4 minus 4 would equal 0. But anything more than 4 right there would cause this to be a negative number. So if we set this up and we say 4 minus x squared has to be greater than or equal to 0, because 0 is okay, we just can't have a negative. Let's solve it. So we subtract 4, we get negative x squared is greater than or equal to negative 4, and then we need to get rid of the negative. So if we divide both sides by negative 1, it'll change the sign of our inequality. So x squared is now less than or equal to 4. And then we take the square root of both sides and we say x would have to be less than or equal to plus or minus 2. So then we could write that out. Our domain has to have values of x that are less than or equal to, so it's between 2 and negative 2 is what happens. So x is less than or equal to 2, and it's greater than or equal to negative 2, because that would make sense. Think about 4 minus, and then you plug something in for x right there. That could be negative 2. That could be 2, that could be negative 1, that could be 0, that could be 1. It could be all of those values, just can't be anything outside of that range of values. So when you end up with an inequality with the plus or minus, you go with x is less than or equal to the positive number and greater than or equal to the negative number. And then we just had to state it with our D for domain. Okay, so now this video is already approaching 12 minutes, so I'm going to make a second video that focuses on finding x and y intercepts. So this was the first part of part 1. There will be a second video to talk about x and y intercepts.